All right, so here we have if-else statement. So there is two conditions and three statements. One of them else has no condition. So how to basically translate this? I think the first step, like that would be the best thing, is to actually first try to do the flow chart for the existing one. So for example, if we kind of follow the same order that is going on here and basically just try to draw the flow chart. So I'm going to use n and m for um, so that's n. So let's do, this is a condition that we have. So n is equal to m. If that is true, so if that is a yes or true, we're going to have flag is equal to 1. So flag is equal to 1, and that's the statement that we have. If this is false, so if this is a false, we're going to check another statement. So we're going to check the else if statement. So there is nothing new. Here is the basic if statements that we have. Num is not equal to 0. So that's the second thing we check. If this is true, we're gonna assign, I think there is an equal -1. So we're gonna have flag, I'm just gonna put f is equal to -1. So if that is true. If it's false, so if this is false, we are going to have, I'm gonna squeeze it here, we're gonna have f is equal to 0. So basically, this is very simplistic way of putting this one. If you look at this one, you actually notice that it doesn't work exactly as we want, because if this is equal, if it's true, um, it's gonna basically set the flag to 1, but then after that, it's gonna go here because it's always like going straight, right? Um, so it's gonna check the other condition. So actually, we do need something here to take us out from this. So to after of the statements. Same thing happens here. So if we put it to -1, we don't want to put it to 0 after that because we are already here, right? In this statement, we would jump out. So also this one would exit after this. So after running this, it should go after and continue. So this is basically what we have. So if we want to now do this in MIPS, we said that we want to have this all these truths to false. So all our straight line, we want to be false. So how do we do that? I'm going to switch the statements. So instead of n is equal to m, I'm going to put n not equal to m. So that's our statement. Now my true and false going to switch. So my false going to be this way, and then this is going to be true. If it's false, we are running this statement. So flag equal to 1, and we are running that statement. If this is false, you see that we made this false, we switched this only because I negated this statement here. Otherwise, we could have not done that. And then we still need the same jump. So that's going to be there, nothing new. Because after this, we have to exit. We're not going to run the other stuff here. But then after that, we're going to have another condition. So that's our else. So n is not equal to 0. So we want to switch this one because it is true also. So this is going to be n is equal. And that's like a double equal to 0. So then this one would come here, or true. So similarly, this one we had true. I did switch these, so I made this negate, and I have the negation of that. So here we have now false, and our true statement gonna be here, which I'm gonna continue. If it's false, we're gonna have our same statement. I'm not gonna write it. So same statement as here, and then we have another statement, which is gonna be the last one, and this is basically getting there. So same thing. The only difference is that we negated this and we switched the true and false. And also, of course, for this box, we do need after that we need to exit. So we're not going to continue. So basically, this is how we can switch one flowchart. First figuring out the original flowchart, and then after that, getting the flowchart that is equal to the original one, but it's very straightforward for us to basically convert that to MIPS assembly. So from this modified flowchart, we can easily write the statements. So if you look at the next slide here, we basically have that what I was drawing right now. So we see the original flowchart, and also we are seeing how it's modified. So it switch these, the true and false, there's negations, and so on. And here is the original code that we had. So just to follow it easily. So here we are actually converting the if statements that we had to assembly language. So we are following this flowchart, and we know that is equal to original one, but we are following this again because we have all the nodes or going to the next statements on our straight line. So that is going to be very straightforward to convert that. So let's look at it. We have num is not equal to max, and if it's not equal, we're gonna have flag is equal to 1. So we have B and E, branch not equal. These two are num and max. And then we have test 0, which is the next if statement. But if it's false, this one, as we had here, is a no. We are doing our flag, and then we have a jump. So this is the same thing. If it's false, we are basically doing our flag, and then we have a jump. We are just having an unconditional jump to go to the end of the if statements. So far, so good. For the second statement, or second condition, we have an equal. So we're going to have a BEQ here, checking something with 0. And if it's false, we have flag -1. So here we are checking that num with 0, and that's a BEQ. If it's false, the next line gonna execute, and that's setting flag as -1, and then we are jumping as usual. If this is true, it's our else. So if this was true, we are going to flag equal to 0. And that's gonna be the else, which is setting the flag to 0. So kind of a straightforward translation from the modified flowchart. So what about if you have constant? We have to use kind of temporary variables. So for example, you can use a T0. If you want to check something with a constant, you can put that 5 to T0, and then you have to use that T0 in your branch instruction. So that's kind of like a two-step. If you are using Mars, you can actually put the constant directly here, and Mars does this for you. We have other conditions also that are dealing with 0. So it's kind of shortcuts also. So you are just giving it 1. So this is like kind of like branch is equal or greater or equal than 0. So it's just checking S0 if it's greater or equal to 0. And then you have your jump label. So similarly, you have greater than, less or equal, and if it's less than 0. So basically, those are your conditions that are directly working with 0. And these are going to be used actually in machine code more often. And you see that some of the instruction that we are using are actually pseudo instructions. But that's for later.